Hello. Let us briefly talk about probability and what it is exactly. So, what is probability? In short, it is a function. Probability is a function. Let's recall what a function is. A function maps one element in set A to an element in set B. The same goes for probability. It essentially maps random events to a number within 0 and 1. Then we can use the number to talk about the probability of a given event. In our daily life, we sometimes see statements such as the first statement, this stock price is more likely to increase, the risk of default is getting higher, chances are tomorrow is going to rain. Those are predictions. And there are many other relevant words such as coincidence, lucky, or randomness. How do we formally discuss these terms? We can use probability, which is used as a measure of uncertainty and random events. But how does it work exactly? A natural thought would be assigning numbers to those random events. The larger the number, the more likely the event is going to happen. In this way, we can quantify the uncertainty, right? This is similar to measuring one's height. So pick up one people from a group of people, use a ruler to measure the height. You assign each people a number to represent their heights. The larger number, the taller. Note, the above procedure is also a function. So you have a group of people. You map those people essentially to the number to real numbers, right? You pick up one element from this set, a group of people. You use the ruler to assign a number to these people. For example, 180 centimeters, belongs to the set of real numbers. So essentially, the whole procedure satisfies the definition of function. It maps one element to set A to another element in set B. And the same goes for probability. So it relates random events to real numbers within 0 and 1. Let's formally write it down. If S denotes a set, a collection of all possible outcomes, our sample space, and A is a random event containing selected outcomes, right? So it's a subset of S. We're gonna use probability to map A to a real number within 0 and 1, between 0 and 1. If we go back, if we return to the first example we discussed, we can use A to represent the event where the stock price increases, while B represents the event it does not increase. So our sample space is simply the union of set event A and, note here is disjoint event B, right? Because A and B, they don't happen simultaneously. Only one of these can happen. And if we have probability A larger than half, so it's larger than 50-50 chance, we could say the stock price is indeed more likely to increase. Probability is also a special function. It requires certain special structure imposed on this function. For example, it requires any probability functions has to assign 0 to empty set. Well, empty set contains 0 outcomes, so it's natural to assign empty set to 0. We also require any probability function has to assign the whole sample space to be 1. Well, since all the outcomes are in the sample space, so the event, the outcome gonna be in the sample space happen 100% surely, right? So it's also very natural to assign the probability of S, the sample space, to be 1. The third one, sometimes referred to as the countable additivity, is a little bit hard to understand. It looks hard on the first sight, as it involves a sum of infinite series. However, the background story is simple, right? Suppose now we have a bunch of destroying events, AI, and those events are destroyed, so at most only one of these can happen. Then the probability of one of these events happens. The third equation simply requires that probability has to be equal to the sum of individual probability. If we choose, for example, only 2 non-empty random events and let all the other events to be empty set, so they are zeros, we don't care for them anymore. The third equation basically implies the probability of either A or destroying event B happens should be the sum of their individual probability. Return to the example, where A represents the event where the stock price increase, B represents the event it does not. Apparently, we should have the probability of the union should be equal to the sum of individual probability. In this way, I guess the third equation is not that hard to memorize, right? In short, probability is a function with special properties. It assigns numbers from 0 to 1 to arbitrary random events. Then we can use this probability to quantify. Use these functions to quantify our random events. We transform them into numbers, which we can easily calculate and compare. Thank you for watching these videos.